So, in stage 2 of metabolism, there are specific metabolic pathways that are used to convert glucose, fatty acids, and amino acids to acetyl-CoA. So, the pathway is specific for glucose, there's a specific pathway for fatty acids, and there are specific pathways for amino acids. So, we'll get into more details of what those pathways are later. But for this video, we want to dive into what is acetyl-CoA and how does it work. So once we've gone through these specific stage 2 metabolic pathways to get glucose to acetyl-CoA, or to get fatty acids to acetyl-CoA, or to get amino acids to acetyl-CoA, how does acetyl-CoA function? What does it do? So again, each of these digested molecule types, whether it's glucose, fatty acids, or amino acids, will enter its specific stage 2 pathway to then become acetyl-CoA. So what about coenzyme A? It's pretty special, so we need to dive into it. Coenzyme A is really a shuttle for this 2-carbon acetyl group. So we really refer to this acetyl group as a 2-carbon group, or even as C2. So what does coenzyme A do? It delivers this 2-carbon group to the citric acid cycle, to stage 3. So we've just finished stage 2, and we are moving on to stage 3. And coenzyme A is a big part of getting from 2 to 3, about shuttling this 2-carbon group from stage 2 to stage 3. Coenzyme A, however, is not an oxidizing or reducing group. We've heard that about our other coenzymes, and this one is not. So that's one unique thing about it. The active part is what we call a thiol group. It's a sulfur to hydrogen group. So oftentimes when something contains sulfur, it's called a thiol group. So this SH, or or thiosulfate, sometimes people will call it, but this SH is really this thiol functional group. And so there's 2 forms of coenzyme A. There's CoA, with that SH. Sometimes it's referred to as SH-CoA or just as CoA. And then when it's got the 2-carbon acetyl group, we call it C2. Okay, so what does that conversion look like? We'll have a CH3 and then another carbon. That's our 2-carbon group. And then the second carbon is double bonded to an oxygen. And then we'll have our sulfur, and then we'll just write CoA for coenzyme A. So it goes from the thiol CoA, which has hydrogen bonded to sulfur bonded to CoA, and then it goes to acetyl-CoA, which is CH3 bonded to carbon, double bonded to oxygen, so a ketone, and then that carbon is bonded to sulfur and to CoA. So really, we're replacing the hydrogen in the thiol group with the C2, the 2-carbon group, the CH3C double bond O. That's the difference between the 2 forms, whether it's CoA or, CoA would be hydrogen, sulfur, CoA, or acetyl-CoA, where you've got CH3 bonded to C, double bonded to oxygen, and then sulfur, and then bonded to CoA. So those are the 2 different forms. Now we're going to look at CoA in a little more detail. We've got our thiol, our hydrogen bonded to sulfur. It's bonded to CH2, CH2NH, and then that nitrogen is bonded to a carbon that's double bonded to oxygen. And then it's bonded to CH2, CH2, it's bonded to then NH. That NH is bonded to a C, double bonded to an O. So, those 2 pieces have been mirror image, have been the exact same. And then that C double bond O is bonded to a CH that's bonded to an OH. That CH has a carbon that it's bonded to. That carbon has 2 methyl groups coming off of it. Then it's connected to a CH2 and then to two phosphate groups, one after the other. So we're seeing diphosphate. Then we're seeing our five-membered ring with our oxygen and a phosphate group. And then we're seeing our, fused ring system. So, we're really seeing a molecule that's kind of similar to what we've seen in terms of ATP and ADP. We don't have to memorize this or know what its structure looks like. I just wanted you to have an idea about what it's like, what coenzyme A is really like. So, there's our deep dive into coenzyme A. Here's the thiol group that on the end, that hydrogen, where that can be replaced with the acetyl group. So if we had a 2-carbon acetyl group, like this, like a C2 group where we've got CH3 bonded to a C, double bonded to an O, and then we come across thiol-CoA where it's HS to CoA. What we notice is that 2-carbon group, CH3C double bond O, replaces the hydrogen and is bonded to sulfur and CoA in our product. And then what happens is, if we continue to look at what happens to acetyl-CoA, this bond between the 2-carbon acetyl group and the sulfur can be broken to sort of free up this 2-carbon piece. And that 2-carbon piece, this C2 in the end, which here we've got CH3 bonded to C, double bonded to O, and that C is bonded to an O minus, that 2-carbon piece, or that C2, that's what's going to go to stage 3, to the citric acid cycle or the Krebs cycle. So this is going to go on to stage 3 right here. And then it frees up coenzyme A. So when we break apart that C2 or that acetyl group from acetyl-CoA, we free up CoA again, to be reused. So now CoA is freed up as HS to CoA. So again, the big role of CoA is to shuttle this 2-carbon acetyl group. Now, how we derive or get acetyl-CoA from these different specific metabolic pathways in stage 2 is something that we're going to get into more detail in later videos.